All right, we're back, fully rested and ready to really finish this time, okay? So thanks for watching the series, DiSco MIMO, you know the story. We're pretty much done with the plots, almost done with the code, okay? So final goals for today is to, let me add this nice plotting box here. Okay, so we'll finish the nice plots today. And then in one, if you're watching on YouTube, in a very, very, very upcoming or coming soon episode, we're gonna write a new paper. If you're on stream, this is gonna happen today. But yeah, so pretty good, right? Yeah, so we're also gonna write the paper on this channel or on stream, wherever you want to watch it. Thanks for watching, thanks for the follows, subs. So let's get back to it, right? And this is kind of already, we're close to writing, right? Because the last thing I want to do about the code is I'd like to, I'm sorry, whenever I write the paper, first I like to have all the figures and all the results ready, right? So that's why today I first want to finish, in this episode, I want to finish the remainder of the plots. It's going to be a short paper, 4 pages. So we only need 3 figures and 2 result figures and 1 block diagram, okay? So we just need 2 result figures. So let's get back right to it. And actually the plots has already become sort of a sub module by itself. Because what I want to do is I just want to be able to run UV run plots and all the plots happen. One of them is kind of there today, so I call it pentaplot because we're going to plot 5 curves for the paper. Because remember, we were able yesterday, or in the previous episodes, we were able to reproduce the sort of the sampling twice so that it looks nice. But when we actually try to measure how good sampling is, the results are mixed. So we're gonna have to write a paper about this. But first, let's make this plot better because there are 5 data sets here that I'm trying to show. I'm trying to show 2 training data sets, the first 2 curves, and then 3 synthetic ones. So maybe the first thing I want to do is I also need a line marker for this plot, okay? Because I want to plot them differently. So where is plots? Line styles, right? So we'll have dash, 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 and the synthetic data can be continuous, okay? So then we'll also take these line styles. We're gonna customize the plot as much as we can. CDF, so it'll take line styles, list of string, and we'll say for line style and line styles, and I believe the plot is, yeah, it's line style equals line style. What else can we make here? We should set the global font size, and I think it's RC params font size. We can go higher. We should go like an 18 or something because we want the plot to be nice and large. We should not override this font size then. Cumulative distribution function is fine. Maybe a bit thicker lines. We can add markers, but we don't want to add markers No limit, let it pick its own limit. Location best, sure. DPI 300, box inches tight. Let's see how this looks like. And the other plot I want to make, so this is one plot. The other plot I would like to do for the paper is plotting the training curves. Let me see how this pentaplot looks like. Kinda there. Font size is good. Okay, the font size is way too large, and also the legend font. Does the legend not have a font size? It doesn't. So I need to look at this up then. Matplotlib legend font size. Oh. Okay, so let me just do it per rams then. Well, actually, no, wait. So can I not just do... I can't do font size to this. Damn it, I really don't like this thing. Maybe I can. Okay, this looks a lot kind of better. Huh. So we have 2 training data, 3 synthetic data. This is clearer now. But this legend looks ugly. So why don't we give it a bit more white space on the right, and then put the legend center right. So plt dot. Okay. So matplotlib split label in legend across new lines, because I have an idea. Okay, so it should be -n. Okay, so here's what I want to do. What if we split the legend? So we do -n training data. What if I give it a bit more white space? So set x lim from 42.5 to 80. And what if for the location I pick right? What locations do I have? Center right, PLT legend location. Is center right possible? Oh yes, it is. Center right. And I gotta shrink it a bit. Font size 12. Now, because the reason is my paper is the template is a double column template, but it's still a bit wider, so maybe I can still use a let me see what's happening. How does this look like? Okay, it's looking good. So I need to cut synthetic data. Okay, it's kind of getting there, right? So we can also boom synthetic data, more space. Let me give it a bit more space, an 85. This should do it. Okay, what do we have here? Okay, starting to look pretty good. It's kind of there. Just push it just a bit. Come on. I can make the figure wider a bit. So if I make it a 7/6, how is this gonna look like? I think this is it. Just a bit wider because I think that it works better for the format too. Let's see. Aha, yes, I think this is it. Okay, good, perfect. So we have 5 curves. And these are the results. We'll have to write about them. I would say this is a pretty damn good figure. So I can just upload this to the paper. So here's the other thing I do is now let's go to the template, which is in latex. Okay, we're gonna have to talk about this tool, but this is the template of the paper we're gonna write. And what I do is I keep a figures folder. I'm just gonna upload it. Where am I here? Score based, DiSco, because I want to see how it actually looks in the paper. So it's called pentaplot. Okay, it's taking a while. There we go. All right. And where is the sample image? Oh no, Franklin, what is it? Okay, so then finally we don't need this. Pentaplot. We don't need a description. My whole point is I want to see how it looks like in the paper. It looks pretty good. I gotta tell you, this is readable, right? So what I'm looking for is the font size being the same size as that of the paper. Possible image without description. Not sure what this is. Oh. Oh, I see. They want you to... Okay, this is something new. It's for accessibility. Okay. Description. Okay. Okay, other things we can do. What should we do here? I don't know. We can't make the font consistent. It's too annoying, right? Probably. This looks pretty good though. Looks pretty high resolution. We could make it a PDF, but then there may be some other rendering issues. Let's leave that for more latex work. I think I'm pretty happy. This is one of our results, basically. We're gonna have to write around it or comment what the heck we did here. Actually, it seems we're most successful in... No, we're pretty successful in generating synthetic data, right? The orange and the red curves, they should be close to each other. The original paper has more issues, but it's because of its sampling. Okay, we have a lot to talk about. Good, in the paper. The other paper now, before we start writing, and after this, we're kind of done with the plots for good, right? So we can call this nicer name, CDF plot, okay? The other paper I didn't do yet, because the other plot I didn't do yet, but it's a bit easier because so let's just load. I want to load the loss curves too, right? So we're gonna return a tuple because we have everything loaded anyways, okay? And we will say loss is numpy as array. So what did we call the loss in our training code? I believe we called it train loss log. Okay, and this will be a float 32, and I don't remember what is it called here, but we can just breakpoint and find out what it's called here. In the legacy code. So basically I just want the basic training plot to show that both the reproduction and the original paper, they go to that mythical about the 100 value we saw. What do I have in contents now? Oh, I know, I see. I don't have it here actually. Oh shit, I can't do this here. I'm gonna need a new function. Because the loss is load loss. Very annoying, but we have to do it like this. And the reason why we have to do it like this is that the loss is in a different H5 file, unfortunately. So if use H5, okay, so loss will be loss. Okay, what do we say this is? And then loss will be something, none. We'll have to breakpoint here. What is the loss here again? Train loss log. And it's a float 32. The only problem is we're gonna have to load the loss. Okay, so now to plot training curves, we shall do the same thing. So if the length is not the same, then we're gonna load the data. Okay, so we'll say if the length of paths labels is not the same, okay, we're gonna plot the figure, and we don't need to transpose anything here. Maybe we need line styles. Probably not for this one. So then we can say loss. Okay. And then we just have to plot it actually. So it's the X will be range from 1 length of loss plus 1 loss, label, label, line, line. Okay. Then we just have to wrap up the plot. So we wrap up the plot, title, training loss, exponential moving average, step, the legend we can leave up to a best. Let's not do the limits, tight layout, close. Good. So then what we have to do is we have to call plot training curves. Now the training paths are different, okay? So training paths are, because unfortunately the loss is found in the model file. Oh wait, which is also true for me actually. Wait a second. So there actually there's nothing wrong here. So my thing will have models too, because ours will be models paper. Okay, CDLC / weights step 124.799.pt. The second model is, okay, so we're gonna need training paths. What do we want the labels to say? Original training, refactored training, training labels, and what else do we take? Oh yeah, uses HDF5, true, false, and name, training.png. Okay, so the only thing is we need to figure out where the heck is the model, because it's in up, score based channels, models, score, CDLC, final model. Model, score, CDLC, final underscore model. Model score to zip, final underscore model.pt. Okay, and I should get exactly the same. The only difference is I need to finish. I don't know how to load the loss here. So let's let this run now. Okay, so pre-commit run all. Missing word. Where do I have line styles? Missing plot CDFs. So CDL. Oh, sorry, I broke CDL. Yeah, because I changed my plot code and I use it in CDL too. Line styles. Continuous. Okay. Pre-commit run all. We're done here. All right, so chop gotta run the plot. So UV run group torch plots. Okay. Let us see how this looks. Aha, it's a torch actually. Oh, I see. So the training is always a torch, is it not? Yes, it is. Good, very good. So it's always torch load. Map location is CPU. I'm gonna do a trick here. I'm gonna leverage UV even more. Legacy, right? So if it's legacy, we'll have to breakpoint. Otherwise, I know it's contents. What was it? Oh, okay, here it is. Train loss log, which I believe is already NumPy. So the thing is, if I import torch here, I'm gonna have to delete the, that's okay. I'll delete the plot from the CDL. Oh, did I say load? Sorry, I meant load loss. Legacy. Is legacy. Legacy. Interesting. So I need dot map too then. Okay, it's not the worst. UV add dot map, because I can't load the legacy data. So many damages done by. So let's see, what do I do with dot map now? Okay. But can I sync to group torch? I believe I can, yes. Actually, I should remove this score SDE PyTorch, forget about all this. Okay, so UV lock. UV sync group torch. SciPy. I gotta add SciPy back. And let's see, UV lock, UV sync group torch. Let me delete this then. We don't need the plot from here. Let me clean this up a bit. So cfg dot verbose. Okay, so pre-commit run all. We can remove this. And sync to group torch. And UV run group torch plots. Yeah, so I still have the NumPy issue here, so I need this line back. Interesting. This is a silent, I mean, there must be a reason why I added this, right? So UV lock, UV sync group torch. All right, again. Good, we're done now. So what I finally was able to load the legacy file. So length, contents, train loss, I believe it is, right? Yep, so loss. And is it like, let's see what this is. It's just a list, I guess. Nice. So UV run group torch plots. Finally, the second paper plot, come on. Okay, so we plotted, what would they call it? Pentaplot is the old one. What's the new name? Blah, 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 blah. CDF plot, perfect, and training. Aha, we have to smoothen this. We have to smoothen the, because we EMA with 0.99, right? Zero for value in loss from 1 onwards. We're gonna append the previous one times 0.99 plus value times 0.01. So we're gonna smooth this curve out to raw loss, and we're gonna call this loss, raw loss. Okay, that's because we do in our train loss log. Yeah, we do a trailing loss. And it starts from that 109. Okay, good. So let's see it again with that one. And what else do we need? What else can we mess with this in this plot? Label font size can be larger here. 16. Should we do a Y scale semi-log Y? Let's try it. Let's try a Y log scale plot because it does look a bit distorted, right? We want to see some of those details. Oh, I can't wait to get it. Okay, let's see how it looks. Looks pretty good. Nice. So we're able to reach lower. Can I do a grid fine, which both and I think I want that stronger alpha because I really want to see those grids. Very interesting result. So we're able to reach a lower loss. Now the training data is different. So yeah, it's hard to say. We're gonna have to comment on this. Okay. All right. Interesting. Should we do a double log plot? Like log? Something interesting is happening here. We're reaching a lower training loss. But it is what it is. We're just gonna have to write the paper around this. So good luck to us. Not enough time to consider this anymore. Yes, I like the log plot. Okay, this is the plot. Good. So training and CDF plot. I think we're actually done. Okay, so pre-commit, run all. Let's commit everything we changed. We also messed with the dependencies a bit. We simplified them, which is also good. UV lock, git status. So we changed git add plots, PyProject, UV lock. And what else did we change? Oh yeah, we changed, we simplified MIMO CDL, commit, final plots, and simplifications. And I think it's time we freeze the code for a while and get back to writing for like 2-3 hours. And then we'll see where we are. Okay, so we can push this upstream. And that is it. Let me merge this in DiSco MIMO so it's all in public. Looks clean. Okay, we go git checkout main and pull it. That's it. Let's freeze it. Stop. Okay.